Hey guys, this is just going to be a quick introduction. Hopefully the video is only like 3 minutes long and you can watch it and answer the question then on Schoology. So this is the exact same problem we did in, let's switch it to a cuter February color. We'll do pink in honor of Valentine's Day coming up. Okay, so this is like the exact same problem we were just doing. So remind yourself that when we use the word factor, what we want to basically do is convert this equation, which is in standard form, into intercept form. So basically parentheses. The words factor mean take your standard form equation and make as many parentheses as you can out of it. And the reason for that is really we like graphing in that kind of format, and we also like solving. And that's sort of where we're headed, but that's like days and days away. So the goal here is to make parentheses. And so there is no difference between this problem and literally what we did on the last test, which is it's just a box problem. The only difference is you're not going to do the L thing because we already have an x squared kind of problem. Which, by the way, remember that degree 2 tells us that there are going to be 2 parentheses. We just have to figure out what's in those parentheses. So back to the box. Box problem. Set it up. The x squared goes in the top left. The negative 21 goes in the back. And again, all we're trying to do is figure out areas. So remember what we're doing is that if I said what's the area of the big shape, the answer is 70 because together this makes 60 plus 10. But when I say find the area, most kids don't say, oh, we add the insides together. They say something like base times height, right? And so it's possible that this is maybe size 10. And if that's size 10, then this is size 6 because together they have to make a 60. And if this is 10, this is probably a 1 because if this is 10, then this is 10, and 10 times 1 makes 10. So if you look at the side, it's worth 10. If you look at this side, it's worth 7. And 10 times 7 is the same answer, 70. So the insides and the outsides give you the exact same answer, which is 70. Sometimes it's beneficial to use the inside of the box, and sometimes it's beneficial to use the outside of the box. And so what this question's asking us for is to convert from the inside of the box, where sometimes that's helpful, to the outside of the box, where sometimes that's helpful. So fill it in the same way that we've done before. X squared, x and x. And now we need a combo that gives us 21. Well, the first combo that I can think of is 7 and 3. But that doesn't exactly give me negative 21, right? One of these is have to be probably negative because a positive and a positive is a positive number. So I'm going to just switch the 7 to a minus sign, and let's just see what happens. When I place that negative 7 there, that yields a negative 7x here. The 3 and the x from here give us a 3x. And now when I put the middle together, negative 7x plus 3x gives me negative 4x. And what I'm trying to see is, does this match the middle? Because this x squared matches this part here. This corner piece, negative 21, matches the negative 21 at the end. So I want to make sure that this diagonal here matches this number exactly. In this case, it's pretty darn close, but not quite right, like something is off. And I think it's because I put the minus sign in the wrong spot. So I'm just going to change that minus sign from here and place it here. And that will just change this 7x to a positive 7x and this 3x to now a negative 3x. And now if we put those together, 7x with a minus 3x, well, 7x's minus 3x does give me that 4x that I'm looking for in the middle. So yay, I nailed it. Now all I'm going to do is take the numbers on the sides and put them in parentheses. X with a 7, and it's a positive 7 because I don't see a minus sign there. X with a minus 3. And look, I'm done. I had an x squared, which was a degree 2, and I turned it into 2 parentheses by going from the inside of the box to the outside of the box. So that should be all refresher. Remember, we don't change the signs here. We just leave them exactly the same. We just literally copy and paste from this side to here. So now, what's the difference between what we did last unit and this one? Ta-da! So if you notice, I'm going to copy the problem above. It's all about making unfamiliar problems be familiar. Same, this is where the difference is. But same instructions and same procedure. Factor means parentheses. Okay, here we go. I'm going to start the box problem. X to the 4th. Actually, you know what? That's fine. Negative 21. I still need something that gives me x and x here, but x and x gives me an x squared. I need an x4 there, and so all we're going to do is change this to x squareds. Okay? All that means now is I'm going to change the 7 and the 3. That gives me a 7x squared here. Oops, remember, 7 and 3 don't give me negative 21, so I'm going to use the exact same numbers. Now what's going to go here is negative 3x squared. This, maybe I'll keep the same color scheme. This matches this. 7x squared minus 3x squared is 4x squared. Oh, shoot, that was supposed to be in the problem. Sorry, guys. There we go. Same numbers, though, as the original problem. All that x squared means is that we're going to match this diagonal here and the negative 21 in the corner. So the only change that occurred is that instead of putting x and x here, we're going to put x squareds to give us that x to the 4th. And now we've got an x squared plus 7 and an x squared minus 3. And all that was a copy from x squared plus 7 here and an x squared minus 3 from here. Now, remember, if you were like listening closely, this is a degree 4, so I should have 4 parentheses. And we're going to work on that in class together. But right now, all I want you to see is that this problem is exactly the same as the one before. Same numbers, same strategy, except instead of putting x's, we're putting x squareds. And that's it.